started, and let's go back to, now we've got three functions: explanation, volume, calc, and print results to set up. So let's go to our programming environment, and we will say new project and Win32 console application, and we're going to call this lab 7 as we've done before. Make sure your memory stick is in, and we're just going to say OK. Now it's going to come up again and ask us some stuff, and once that's done, it's a little busy now as it always is, and you're just going to have to get used to this. And we're going to go application setting, empty project, and say finish. So once we've got our empty project up here, we're going to, as before, right mouse click, add new item, and make sure you've got not header files like last time, but cons or C++ file. We're going to call this lab 7a, and once we do that, we're going to then do Shift Alt Enter as we've done before to bring it up full screen, and start by / and title program to calculate the volume of 2 rooms using functions. So that's what our program is going to do. Author, same as before. We're going to put in our name, student ID, and PRG 155, and whatever your lab section is. Date for me today is June 10th. It's going to be obviously later for you, 2009. And description. Now if you read over the lab, what it's going to do is, as we said, it's going to do an explanation. We don't care about that. But what it's going to do is this program will use function, and I'm lazy, so let's go back over here and let's grab this volume calc, Control V, to ask the user for length 1, width 1, height 1, as well as length 2, width 2, height 2, then calculate V1, where we say V1 equals length 1 times width 1 times H1, and V2, and we'll assume that you know this, as well as the total volume, V underscore T OT, volume total equals V1 plus V2. This information will then, then be passed to the screen by function. And let's go back and grab it because it's a little long. Let's make sure we get the typing right. Control C, by function, print results. So that's exactly what we're going to do. And this is going to be a little different than we've done in the past. I'm assuming that if you know volume 1 is V1 equals length 1, that V2 is that. So everything is pretty much described here. Now next step we're going to put in is our include section, as we've always done. And that's going to be number sign. Make sure you do this as number sign include. Now sometimes when you start learning new things like defines, you're going to put defines in here. But it's number sign include. Standard IO.h, which we've always done. And this is going to have the defines, because that's what's inside these files. Defines for printf, scanf, getchar, putString, getString, and flush. And we also have number sign include conio.h, which has the definitions or defines inside it for the getch function if we're going to use that. And number sign include standard lib.h. Now you should not include, you should not include the math function because we're not going to be using the sine, cos, tan, square root, or power function. Because if you put in include math.h, I know you don't know what you're doing because we don't need those functions, so we don't need the defines that are required for those functions. Now, next section, this is the hardest section to do by far, is the function prototypes, because once we have the function prototypes, it's very easy from this to do the function definitions and know how to do the function calls. So let's go back and take a look, and we're lazy, so let's put in explanation. I'll grab that, Control C, and what I'm going to do is leave a space here, Control V that in, hit enter, and what we're going to do is then bring up the next one, volume calc, because it's nice to get the spellings right, Control V, and the last one here is print results. So this is the hard part, is to actually set up the function prototypes for these. Now I think you'll understand that, and you can see this actually from the main here. Let's take a look at what main is. Let's bring this up to, I don't know, about 150 I think. And notice that what we have here for volume calc is that we don't have an explanation, we don't have any variables off to the left here, we don't have any variables being used in here, so that's why this is void, explanation, void. So let's do that one. That's the simplest one to do. So let's just go over here and put in, over here to our left, let's put void, and then in the brackets, void. So nothing in, nothing out, and a semicolon at the end. We're pretty much done that. Now if we take a look back here, we'll notice also that volume calc is the same way. There's no variable over here, there's nothing inside the quotes to pass anything in, and if you think about it, this makes some sort of sense, because inside here what's happening is that it's going to scan all the stuff that it needs, so we're not passing anything in. It can't pass anything back because it's got so much stuff. It's got length, width, height, so that's 6 plus 2 volumes, 8 plus 9 is the total volume. It has 9 things to deal with, and it's not sending any of those things back, and any one variable can't handle all that. So this is going to be, as before, void volume calc void. So let's put that in, because it's not taking anything in, it's not sending anything back to main. And so that's a little tricky. This one's a little tricky. But let's take a look at print results. And what print results is doing, and you can see here, that once you're in here and you're scanning all this stuff, it's going to push all 9 things into print results. It's going to push the length, width, height, volume for room 1, length, width, height, and volume for room 2, as well as the total volume, all into print results, so it's going to print it out. Now, as anything, as we've seen before, anything that generates output in the screen means that it's not putting something back to a variable, it's going to the screen. So the output is the screen, so again, this is going to be void. So let's go and take a look. So print results, and this is tough, but print results up here is going to be void, because nothing is going back as a variable, it's all going to the screen, but this is where it's going to be fun. Float length 1. And it's getting this from volume calc. Float width 1. Float height 1. Float v1, because it's going to do the volume. Now what we're going to do is we're going to put in a comma here and go to the next line, because otherwise we keep putting all this information in, it's going to run off the end of our screen. We want to get nice printouts. And then we're going to put float length 2, float width 2, float h2, not sure where it's clunking, but it's clunking, float v2, and finally float v, and I'll say underscore total. Now the one thing that you'll find with this is we're defining, and this is strange because you're going to hear this term later, anything that we define outside of main becomes what's called a global variable or global function call or function. And what this is really meaning is that anytime you use explanation, it's known through any part of, say, main or any other subfunction you're going to do. And when you get into print results, these variables are being not having to be defined in print results, because they're being defined here and used throughout print results. So we don't have to define them locally inside these functions. One thing never to do is never to say float, integer, char, or anything outside of a function. If you do, that makes it a global variable. Those things we're not going to allow this semester or ever, because it's a very bad programming practice. We're always going to use local variables. In other words, what that means is the variables themselves will be declared only inside main or inside the actual function. So let's keep that in mind. Okay, so the next thing is to put in main. And if you remember, we sometimes to show this in textbook, we have to do integer main, and we have to have void. And this is more like a function definition, as we saw. And one of the things, we're just going to put in the end brackets, so we've got main defined. And let's leave room here again for our function definitions. And all we're going to do to create these function definitions is copy everything except the semicolon. And let's put that down here because we're lazy. Well, efficient, I guess. Efficiency is the height of laziness. So let's put in our, whoops, closing brackets. And so that's that one done. Void, volume calc void, don't get the semicolon. Let's put this down here. Control V, bracket, and close bracket. This is a long one. So let's do that to there. Control C. Let's go down here. Control V. Enter. Back it up a bit. Bracket. And then closing bracket. So we've got the structures that we need for all this. Now if you remember, let's deal with main first. One of the things that you're going to always have to put into main, because we've got integer up here, is the last statement that we're going to have is return 0. You're going to have to get used to typing that in. And remember, return is the last thing before a bracket. All the other code is going to have to go here. So let's deal with the explanation function because it's the easiest one to write. Things we're not going to do is, this is the programmer's explanation. This is a description for other programmers. What we have to do, and we did this before, is we copied and pasted this as the actual explanation to the user. And that was okay in the simpler ones. But this is a little way too detailed for the user. This is more as a programmer's thing. Talks about functions, and as far as the user is concerned, there's no functions involved. It's just doing it. Now, whether we did it as a main line and put everything in there, or did it as functions, that's really transparent to the user. So all the user needs to know for the explanation is just what I have to do as a user. They don't have to know how your car was built. They just know they put the key in, turn the thing, and away it goes. So same sort of thing. So we're going to clear the screen. That's pretty standard stuff. And then we're going to do some put strings. Now again, we can be a little bit lazy here. We know we're going to have a few of these, and and we don't know how many yet because we don't know how long-winded we're going to be. So let's just put a bunch of these in to save ourselves a little bit of time. We can erase whatever ones that we don't want. So this program, so we have to tell the user what the program is doing, will ask you for the dimensions of 2 rooms and calculate the volumes for these individual, Control Z, I love Control Z, Control Z, Control Z, individual rooms, as well as the total volume for both rooms. It will then print out the original dimensions. We're writing a book again, I do apologize. As well as the individual volumes and total volume. And that just seems to work out quite nicely. Now if we want to check this out, one of the things we're going to have to do is we have our function prototype, our function definition. So what we really need is a function call. Now I'm very lazy, and I think you should be as well. So let's go up here and get our function call, Control C it, and let's just put it in here, and Control V. Now the one thing that you're going to need before the return here, and we got another bit of code to put in here, but we should put in our get ch to make sure that we can see our output. Let's punch it up F5 and see what happens. And it's compiling and it's doing some stuff, and it said float should be preceded by a comma. So let's take a look. Let's double click on where it gave me the error. Should be preceded by a comma, and it even tells me. Notice I forgot to put a comma here. Boop. So let's now punch up F5 again and see. So it's pretty good. You just click on where it thinks the error is. Now we've got another error here. It says, let's see, what does it say? Syntax error, float should be preceded by a comma again. Let's see, where's that? Okay, 47. And we did the same thing here. Well, we were consistent, weren't we? So let's put in a comma. Let's try punching it up again. And this time it's doing its thing. That's one problem with copying. If you make one mistake and copy it, you've obviously made two mistakes. Now it's linking and it's running, and let's just make sure that our program is going to run to this point, and indeed it does, and there's our textbook coming up there, and we'll just hit enter and it goes back. So we know that our program is working so far. So the only thing that we've got tied in here is our function call, and those are the three things that we need for function to work. We need to have a function prototype, a function definition, and to tie it in, once those two are done, to make it work, we have to put in our function call. So this is our function call here. Now, the next section of code that we have to deal with is our volume calc, and volume calc is going to do all the real work. It's going to scan length, width, and height for room 1, calculate volume 1 for room 1. It's going to scan length, width, and height for room 2, calculate the volume for room 2, and then it's going to calculate the total volume, which is an easy calculation, but then it's going to push all that stuff onto print results. So let's see how that's done. Go down to the volume calc section, and what we're going to do in here is we're definitely going to have to scan, which means we're going to have variables. So let's put in variable declarations, and we can fill these in as we go once we decide what variables we want. And we're going to obviously have some variables, and if you think about it, we can say float length 1, width 1, height 1, volume 1, length 2, width 2, height 2, volume 2, and also we're going to have volume underscore total for the total volume of both rooms. I think that's pretty much what we're going to have in here. Now we're also going to have we've done our explanation. We've got our variable declarations here. We're going to get user input section, and we're going to also have in this part of our code our calculation section. And we're also going to, even though we're not doing any output per se here, we're going to show that we're pushing all our stuff into print results to do the final outputs. This is, other than just saying, you know, explanation and whatever here, this is doing really the guts of our work here and just pushing our final output down to here to print it out instead of printing it locally. So let's take a look and see what we're going to do. Now there's a couple ways to do this. We're going to say printf quote, and what we're going to say is input L1, width 1, height 1. And this is just as good a way as any of putting in stuff, as long as they know that these are the dimensions that they're looking for. Now we're going to actually F-flush, if you remember, standard in, to make sure that we flush the keyboard buffer so that anything that was in there before is taken out, not going to be used as their dimensions. Then we're going to scanf, quote, and if you remember, %f, %f, %f. Why are we using %fs and floats for these? Because dimensions are typically going to be that way. They're going to have decimal parts. You're never going to get exactly 1 foot or 1 meter. And we're going to put ampersand here. If you remember, without ampersand, it's not going to work properly, and we're lazy, even though it's a small variable. We're going to do Control C and Control V, and we're showing you little tips and tricks as we go. And we'll put a comma. Now, if we're really clever, we can just grab this, Control C, Control V, Control V, Control V. We've got how many variables? 3. And all we have to do is change this now to a W, change this to an H, and get rid of the comma at the end and change that into a bracket semicolon. We basically got this first section to say length, width, and height. So we say input length 1, width 1, height 1. We scan all 4 or 3, And what we're going to do, because we're extremely lazy, is we want to do that again. And anytime we want to do something again, Control C, Control V, Control V, all we have to do is change this now to be length 2. If we're thinking length, width 2, height 2, and all we have to do is change these to our other variables, length 2, width 2, and height 2. So we've got all the information that we need now. We've got lengths and widths and all that brought in. Now we've got everything ready to do our calculations. And even though it's small, Control C, Control V, it's not a very big variable, but V1 is equal to, and I'll length 1 star for multiplication, width 1 times height 1 semicolon. And again, we have a similar calculation, don't we, for volume 2. So we're just going to grab that, Control C, Control V, Control V, volume 2, so change this 2, 2, 2, and 2. And we've got all of our calculation stuff done except for our volume total. So let's grab volume total, bring it down into our calculation section here, and say that that's equal to V1 plus V2. Now, our calculations are done. The hard part now is to print out our output. Now notice that what we're going to have to do here, and you have to be a little bit careful with this, print results, whoops, and again, it's kind of nice because there's a capital in here, Control C, Control V, and print results bracket, and then we're going to put in all the things that we need in the right order. Now we don't put in the word float or anything like that, we're just going to put in length 1, width 1, height 1, and we have to put in volume 1, and then we're going to put in length 2, width 2, height 2, and volume 2, and V underscore total. Let's just make sure we've got the right number of things. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's 9 things. Now one of the things that we could have done, and I do this usually just to show that this is true, when you're sending stuff in, this bucket and this bucket don't have to be the same name. If you happen to look at Lab 6, you'll see that as long as these are in the right order, it doesn't matter what you call these, whatever's in this bucket gets transferred to these, and they don't have to have the same names. So we've got that part done. Our calculations, we're pushing everything into here. Now I'm going to do a little bit of fancy formatting for our print results, and let's get at that now. So let's go to our print results section. Let me just bring this up a little bit. Let's just put in some extra space there so you can see what's going on. And what I'm going to do is I'm going to say printf, and we're going to use some fancy formatting. I'm going to put a couple backslash n's here to move it down. But I'm going to say this. I'm going to say basically %.1f, because we want to do everything as one decimal place, space x, space %.1f space x space %.1f equals %.1f quote comma. Now what this is saying is we're going to put in the actual dimensions. So let's put in our dimensions here as length 1, height 1, width 1, and V1. Now if you think about it, what it's saying here is if I happen to put in 1, 2, 3 here, this will be 1, 2, 3 here, and it's going to say 1 times 2 times 3 equals, and then whatever V1, which is 1 times 2 times 3, will be substituted in as our answer. So this is a little bit of fancy formatting. Let's Control C, let's Control V, because it's the same thing again, except this time we're going to be printing out length 2, height 2, width 2, and volume 2. Now if we really want to be clever, we can even go a little bit further than that. We can say, okay, let's say L1 times W1 times H1 equals. And we can do the same thing. Let's just copy that again. Control C. Let's be really fancy here. And we'll also do one last thing here. We have to say printf, whoops, printf and we can say v total volume equals %.1f quote comma v underscore total. Now let's run that up and see what happens. Let's make sure we have no errors. It's linking, which is a good thing. That means usually there's no errors. And let's see what's going on here. Now notice that it's just printing this up, and if I hit enter, it's coming back and going, what the heck is going on? We've got all our code written, but what did we forget to do? Well, it's doing exactly what it told, or what we told it to do, because we just said, give me an explanation, do a get ch, and get out, because we haven't linked this in, have we? Yeah. Oh. So what we're going to do, let's go back here because we're super lazy. Let's grab the second part that we have to do in our main to make this work. Let's Control C and go back here and tie in our other function call. So let's put that in, and this is our other function call. And you're saying to yourself, well, do I have to do anything with print results? Think about that for a second. When you do volume calc, doesn't it already here call up print results? It does. So let's punch up F5 now and see what happens. And it's doing is compiling. It's got to the linking phase, so even it's our worried us about unsafe stuff. Now it's asking us for dimensions to a room, which is a good thing. Now I'm going to get you to type in 1 space 2 space 3, 4 space 5 space 6, and then hit enter. And what it's doing here is it's saying length 1 times width 1 times height 1 is 1 times 3 times 2. Woo! Something happened wrong there. Did come up with this. And notice our total volume, we should have put that on a new line, but this should be 1 times 2 times 3, shouldn't it? So we got a slight error there, but we can correct that, and we want to put this on a new line. So let's go and see what happened here. Let's go back to our code. And it says length 2, height 2, width 2. Ah, so this length 2, height 1, width 1. So we're going to have to change this around. This should actually be W1. This should be H1 here. This should be W here. And this should be H2 there. And the last thing that we need to do is put in a /n. Let's run this up again. Maybe we might want to put in 2 /n's. Let's run this up, F5 it, and see if this works properly. Because once we have this working, let's see, let's do this again. So this is an easy one for your lab instructor to check out. 1, 2, 3, 4, 5, 6. And you can see now everything's in the right order. Length 1 times width 1 times height 1 is this. Length, ooh, we forgot to change these, didn't we? But everything else seems to be working. So that's one little thing that we have to finish off to make it look just right. This should have been length 2, width 2, height 2. And that's our last bit of formatting. So when we run it up this time, what we're going to do is just copy and paste this in, and everything's going to work. Now if you've watched Lab 6 video, let's do that. 1, 2, 3, 4, 5, 6. Everything seems perfect now, except for, 1 times 2 times 0. What happened there? Let's go back and see. Let's go and click on this. Length 1 times width 1 times length 1. Whoops, that should have been H1. Okay. So let's run this up a last time. There's lots of things that can go wrong, believe me. There's something in electronics and so on that says Murphy's laws, if anything can go wrong, it will to cause the most irreparable damage to the most irreplaceable parts. So let's see, length 1 times width 1 times height 1, so it's done this calculation. So let's just right mouse click, edit, mark, grab all this stuff. Now as I was saying before, one of the things you saw in Lab 6 was that what we can do, let's put this down at the bottom here, what we can do, and this is a good thing for you to try, is it showed you how to debug your code and watch the variables go through the various functions by setting breakpoints and doing all this kind of stuff. I would strongly suggest that if you've seen that video, try it out with this and see how the program works and see how the variables are being passed in to get a better idea of what's going on. Now notice this star. Let's take a look up here. Notice this star up here. What does that star mean? Well, let's see. Let's say File. Let's say Save Lab 7B. And notice right now, or 7A, the star is gone, which means we've made changes but haven't saved them. Okay, so we've got everything done here. The next thing to do, since everything is good to go, is take a look at the last program that we have to write. Okay, so to do that, let's go to full screen. Let's go here and right mouse click. Since we've saved it, we've made sure we saved it since it's no longer a star. We'll go remove, remove, and oops, that was stupid, wasn't it? Yes, indeed it was. Let's go back. Let's say add existing item. Let's bring that back up, because what did we forget to do? Yeah, let's save ourselves some time and effort. Let's grab everything that's down here down to our include section. At least we won't have to do that. Control C. Now let's remove this. You're getting better at this. Right mouse click, add new item, and we're going to add again a C++ file. We're going to call this lab 7b, and again it's remembered all the settings we had for the other one, so we're going to control V all this stuff in, and then we will go full screen, shift alt enter, and let's make some changes. Before we do, let's go over and see what it is we have to do. Let's drop this back down to 100%, slide down, and this thing says write a program called distance that calculates the distance between 2 points. Now, your teacher can show you that this is really just a Pythagorean thing, but what it does here is it gives us coordinates, and once you pump in these coordinates, it should give you this distance. Now, you're saying to yourself, well, this is almost not interesting, but if you're in a space shuttle and they give you the third coordinate, the Z coordinate, you can use this distance to find out whether or not you're going to smash into the space station or safely dock. So this does have real practical applications to it. But distance between 2 points in space could be your space shuttle and the space station. And what we're going to do is put it in this way. But notice what it's saying is we're going to be using define statements. Define statements to do calculations. As I may have mentioned before, information about this I think is at the end of the notes for week 2, right at the very bottom. It shows you how to use define statements to do calculations, and we'll be amplifying that concept here today. So let's see. What we want to do is let's slide over here and change a lot of the stuff. Program, it's not to calculate the volume of 2 rooms, but calculate the distance between 2 points. So, description. We'll use number sign define statements to calculate the distance between 2 points in space. And that's basically what it's going to do. So that saved us a little bit of time. Now we're not going to, or are we? Let's take a look. Do we need functions? Let's go over and read this a little bit more carefully. Your program must have a function called distance. Oh my god. A function called distance that accepts coordinates, blah 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 blah. So let's go over and put in our function prototype section. Control V, and so distance. Now we'll leave a space in here to see what kind of thing it's going to do, and let's see if we can work that out from what it's saying here. Accepts coordinates as x1, y1, x2, y2, then calculates and returns the distance between the 2 points. Now if you read this carefully, these are inputs. We're going to have 1, 2, 3, 4 inputs and 1 output, which is the distance. Now the distance coming out of this, if you've got points in space, again this is going to be float, so if we think about it, we're going to have 4 inputs, 1 output, and they're all float. So let's go back and see what that means. So we're going to have something coming out of this, and the thing that's coming out of this is a float. So let's do that. Why is this being nasty to me? Come on, there we go. So, whoops. So we're going to have float coming out, but we've got 4 floats going in. I'm going to call this float A, float B. I'm going to use different variables, float C and float D. Now unfortunately you can't just say float a comma b comma c comma d. It won't work. You have to have this, and away we go. So there we go. That's our function prototype for this. Now again, we're going to have to integer main void. Let's put in our bracket. Let's put in our other bracket. But also remember that we have to do down here is return 0. So let's just remember to always put that in. So we've got that happening. And our function prototype, let's make this into a function definition. Before we do that, let's put in the words down here, function definition, so we remind ourselves what this area of code is. So we're going to grab everything except the semicolon. Control C. Let's Control V it in. And again, we'll put opening bracket, ending bracket, just so we have that structure there. So we've got everything ready to this point. We've got our function prototype, and we've got our includes and everything else. Let's see what else we have to put in here. Now it did mention about defines, and let's see. It says have at least one define used for doing this calculating. Now notice this is x2 minus x1 squared plus y2 minus y1 squared and the square root of all that. Square root and squaring. Oh my god, we're going to need a square root function. We're going to need a raised to the power of function. So I think if you remember back to what we did previously, none of these functions that we've got definitions for will work. We're going to have to, and this is the second time we've used this, include what other IO package, or header file rather, what other header file? You got it, math.h, because we're going to be using two functions out of here. We need the defines for, remember, sine, cos, tan. We're not using any of those, but we are using power and square root. We'll be using both of these today. So because we're using two of these, this particular function and this particular function use defines in this file, we're going to have to include it. Even though we don't need sine, cos, tan, we're going to have to include this. So we've got that set up, and the other thing we need is a define section. Now it's all this stuff usually goes above main. I'm going to put in my define section here just above the function prototypes, but you can put it anywhere in that section at the top. It makes sense to have the programmer's block first, include section, so you can see what header files you're going to need, and the define section should really go next, because sometimes, as you saw earlier if you looked at the last video, we actually changed the defines and changed how the program ran, which was pretty cool. So if we want to do that, I think our define section should go next. Now this is the hardest part to figure out initially. So let's take a look and see how we're going to use the define section to actually do the calculation. Is you start off obviously with number sign define, and what you do is you put in a name, a label name, and our identifier. And identifiers, as you know, can start with uppercase or lowercase letters or underscores. After that, they can have uppercase letters, lowercase numbers, underscores, and digits. So I'm just going to put in D because I'm lazy. And then you specify the parameters that you're going to use. I'm going to use x1, x2, y1, and y2. And that's the parameters that I'm going to use for my define macro. This is called a define macro, where it's sort of like a function, and you're saying I'm using these parameters, but it's a little bit shorter version than that. Now let's see what we have to do. Let's go back to here, and it's x2 minus x1 squared plus y2 minus y1 squared, and do the square root. So let's just do this part first. Let's figure out how we can do this, and using the power function. So let's just leave some space here. Power of x2 minus x1 bracket, and if you remember how the power function works, I'm just going to put another bracket over here, x2 minus x1 comma 2. Now what this means is that whatever's in here, this difference is x2 minus x1 to this power. So this is x2 minus x1 squared. So let's go back and take a look. So that's that part, x2 minus x1 squared. This is x2 minus x1 to the second power, and notice this bracket should match this bracket should match this bracket, and everything's ready to go. Now we also have over here plus y2 minus y1 squared. Now I'm lazy, so I'm just going to say, okay, we did this, Control C, plus Control V, and this is y2 minus y1 squared. So we have here is this is going to be, if we look at it, let's leave a little bit of space in here. What we're saying is this is x2 minus x2 minus x1 squared, y2 minus y1 squared, and what do we need? If you look at it, what we've done is we've actually right now coded up and defined all of this. And all we really need is to do the square root of all of this, and we're done. So let's take a look. How do we do that? Well, we say SQRT bracket, and then at the very end of all this, we put a bracket. Now you got to be very careful that everything's going to match and done exactly this way, because if you don't, even though it may complain, let's just move this back now, should only be really one space between these. So what it's saying is when you pass in an x1, x2, whoops, this should be x2, y2, let's get this right, geez, I really messed up, didn't I? This should be x2, y2. Whoops. x1, y1. Boy, I'm really having a great day. So x1, y1, x2, y2, it's going to do all this kind of stuff. Now let's just make sure we've got this set up right. Yeah. So we're putting in coordinates x1, y1, x2, y2. It's going to do x2 minus x1 squared plus y2 minus y1 squared, and do the square root of all that. Now if it complains about a function like this or any kind of calculation, excuse me, then chances are this is where the problem is going to lie 9 times out of 10. And 9 times out of 10, what's missing here is there's going to be brackets that don't match. So make sure you have it exactly as you see here. So it's number sign defined, d, x1, y1, that's the first coordinate, x2, y2 is the second coordinate. This is how we're going to use them. So once we've got that done, we've got our define macro. And as we said before, these are the parameters you're passing in. This is how you use them. And once you've done that, all we have to do is pass something into here, and right away it's going to return a value to us. So let's see how that works. Now let's take a look and see how this program is supposed to work so we can finally figure out how to put it together. It says your program must have a function. We've used that. But what I'm going to do is a little different. I'm going to use this without the function, but let's see what it has to do. Your function must call distance from main and pass it these values. The function must pass back to main the calculated distance. Now instead of using the function, I'm just going to use the define to show you that it works, and then tie in the function distance later. So let's try that out. And as it said here, we're going to have to, in main, grab the information. So that means that we're going to have variable declarations, and we're going to say float, and we've got our variables. Let's put in x1, y1, x2, y2, and we'll also put in, I don't know, d underscore total. So our so that's what we're going to have for variables. So we've got our variable declarations. In main, we're also going to have to probably explain to user, even though it doesn't mention that anywhere. And then we're going to have to get user input, as we've done before. We're going to have to do calculations. Now we're going to do them in 2 separate ways, the calculations. And one time we're going to do it just using the define. Then we're going to tie this in with the define and show you how this works. So let's do the explain to user, and we're not using a function for that. Let's keep this fairly straightforward. Let's do a system clear screen, and again put string, and I don't know, let's just grab that and figure out how roughly, control C, control V, boop, boop, boop. Let's just put in some stuff. This program will calculate distance between 2 points in space. You will be asked for bracket x1, y1, bracket x2, y2, whoops, comma y2, and then it will calculate and output the distance between these points. Not pints. I'm thinking about drinking already. Okay. And let's just put in one more put string just to leave ourselves some room between this and it comes after this. So there's our explain to user. Get user input. Now I'm going to use something a little bit fancier this time. I'm going to say backslash x1 space y1. And I'm just going to put this in. So this way it's going to ask for it. Whoops, I forgot the quote. You notice that without the quote it's not showing the brackets properly. And I'm going to f-flush as we always do. Standard in. Flush keyboard buffer. And we're going to scanf. Slide this down so you can see a little better. %f, quote, comma. And then let's take a look at the variables that we're using. We're going to have to put in an ampersand. And let's put in Control C, Control V. Let's put in a comma. And let's grab that Control C, go this side, Control V, and change this to Y. And we basically have that part done. So there's our first part of our input. Now we're going to have to ask for this again, but it's going to be slightly different. So we're just going to grab this, Control C, Control V, Control V, X2 this time, Y2, X2, Y2. And we've got everything pretty much set up for our keyboard input. Now the calculations, what did we use for that? We're going to use dtotal. So let's grab that. Let's go down to our calculation section. Dtotal equals. Now here's what I'm going to do. This is kind of different. I've called this up here D, right? So we're going to say is we want D bracket x1 comma y1 comma x2 comma y2. And what it's going to do is, without even using a function, it's going to use this define statement to actually do the calculation. So if I happen to type in 1145, it's going to pass up here 1145. It's going to then do the calculations based on 1145, generate a number. When that number is generated, it's going to come back into dtotal. Pretty cool. So what we're going to do is we're going to then put in some fancy output format, printf. Let's leave a couple blank lines, a couple backslash n's. And then what we're going to put in is bracket x1 comma y1 bracket equals bracket %.1f comma %.1f bracket, and so it's going to actually show the coordinates. x1 y1 is that quote comma, and then we'll put in x1 comma y1. And what we're going to do is again do the same thing. We're going to generate two things. It's going to show us what the original coordinates were. Control C, Control V, Control V. So we'll take out one of these because we don't need an extra line there. So this is going to be x2, y2, x2, y2. And then we're going to say printf. Let's put in a couple backslash n's. Total distance equals %.1f, quote, comma, and I'm lazy, and I don't want to make mistakes, and just put that in. And again, what we need here is a get ch. Now hopefully everything's going to run. So let's give this a shot and see what happens. Hitting F5, let's see, compiling. Oops, we've got a serious error. 2 errors, 0 warnings. Float should be processed by a comma. Now it mentions 2 lines, so let's just double click and see where that error is. It says on line 19. Oh, we're missing a comma. And we're consistent, so let's put a comma in here. Even though we're not using this, it does complain about it. So let's F5 now. Let's see what happens. And let's see what else it's saying. 1 error, 3 warnings. distance must return a value. Now we ran into this problem before. Let's go to the line that it's mentioning. Let's just double click. So since it has to return a value, what we're going to do is we've got this, and here's what we can do to get around this problem. If we don't want to use it, we can just comment this out. Let's see if that works. Does just commenting that out work? No. And again it says this, so let's comment out also the function. It means that we're not getting rid of it, we're just going to comment it out. So let's do a / star and a star / and let's see if we can get around that problem this time. And it's linking, good. So even though most of the times we don't have to worry about this, sometimes what we have to do is, if it's going to return a value, just comment it out, leave it in there, you got it fleshed in. Now let's take a look over here. Let's see if we can find out which values we should use. Now I think 1 space 1, 3 space, no, 4 space 5, and indeed it does work. If you check on your sheet, you will find, and notice this really nice fancy screen formatting. It says x1 y1, you type in 1 1, you type in 4 5, and the reason I didn't put commas up here is because I want the user not to put commas, because putting commas in here really can mess things up. So it's doing that, and then it reformats. It says this 1.0, 1.0, 4.0, 5.0, puts these in, and then does a calculation in a nice format. So this indeed does work. And notice this is a short form of using, and again, make sure that this is perfect. If you're having errors of anything now, this is where it is. Make sure that these brackets are exactly what they should be. D left bracket, right bracket here, make sure the commas, there's one bracket here, two brackets there, a bracket. Make sure that the number of left and right brackets match, and everything should go as we've done here. If you're having any problems, that's where it is. Now it did say that we need to use a function. Now what it said is we have to call up the distance function. So let's activate this. Let's activate this by taking this out, and let's take out our multi-line comment around here. Let's reactivate this code here. And what we have to do is say, okay, it has to return a value. Now where it's doing the calculation is d total equals this. Now what I'm going to do is, what's the name of the function? Distance. Well, let's just double click, Control C, and change this from D to distance. Now it's not going to do anything yet because we haven't got any code here and we have no return statement. Now that's what it needs. Now I'm going to be really clever here, and I hope you follow through with what I'm doing. Return bracket, and what I'm going to do is I'm going to return what? This. Isn't that clever? Let's see if that works. Control B. Return distance. Now we're going to need another bracket. So these brackets, left and right brackets, have to match. So what I'm saying is that when I want to call up the distance function and pass in ABC, now I'm not going to be using ABC here, or am I? So A, and one of the reasons I'm doing this is to again emphasize that it doesn't matter. Whoops, that should be a C. It doesn't matter what variables you call these things as long as you're consistent. So if I type in here, let's take a look. If I type in the same 1, 1, 4, 5, this is going to be 1, 1, 4, 5. It's going to pass into the D function 1, 1, 4, 5. And up here, it's going to do a calculation based on 1, 1, 4, 5, 1 for x1, 1 for y1. So it's going to, should work. Let's punch it up and see. Now this is kind of a strange way of doing it. It's really saying, it's like government, okay? In other words, this is the guy here that does all the work. There's all the work being done. This is a calculation. We saw that it worked quite nicely. But here's how the government works. It says, okay, you got to pass it to this guy here. And what does he do? Does he do anything real? No, he just passes it to this guy with the appropriate parameters, and it just works. You got to love government, don't you? Linking. Let's see if this works exactly as before. And let's type in those same things, 1, 1. And notice if I type 4, 5, it's going to flush out the 4, 5 and ask for 4, 5 here. And indeed, it still works. Now this is kind of strange, and it's just trying to illustrate a point about governments and other things as well. is that if you pass something off to this guy, and he'll just say, okay, I've got it, I just pass it off to him, he gives the stuff back, and then I return it from him back to you. It's the way upper management works. But anyway, so we don't really need this function. It's sort of just passing stuff back to a defined macro that actually does the real work. And notice, as long as we're consistent, we use x1, y1. These are just 4 buckets. x1 becomes A, y1 becomes B, x2 becomes C, y2 becomes D. And then when you pass these back, A becomes, when you go up here, A again becomes, this becomes, when you pass it up, A, B, C, D becomes again x1, y1, x2, y2, because these are just buckets that you're throwing stuff into these buckets. It does this and passes back a number, and then that number that's passed back to here gets passed back to here, and everything just kind of works. Now, I would strongly suggest that if you haven't done this in the first example, that you try using setting breakpoints, see how things work, and get an idea of what I've said to you today, make some sort of sense, and we're pretty much done the lab, except for one last thing to do. And what's that? Let's run this up one more time, and let's do this as a keeper. 1, 1, 4, 5, and you can try out the other values in the lab, and you should. Let's right mouse click, edit, mark, grab all of this stuff to here, right mouse click, enter, and once we've done that, let's get rid of this, go right down to the very bottom, Control V, /, and we're ready to go. And let's notice up here again that this has not been saved, so let's make sure we say File, Save Lab 7b, and this goes away. At that point, we're done the lab. And as I said, please try and set breakpoints, check this out, and see how this works. Catch you next time on lab number 8.